we decide to choose parabolic dish antenna aka satellite dish as our chosen antenna to broadcast television programs. They are called parabolic because they have a cross-sectional of a parabola. They have nice visual and good sound quality since they are free of signal compression. Besides that, they have high directivity and highest gain of any antenna type. In the center of a parabolic dish, they have a parabolic reflector which are used to gather energy such as light and radio wave, and because of the parabolic geometrics, they can accept and reflect energy from distant sources. This process is aided by the vertex antenna, normally located in the dish center, to help with the collection process.
The objective of this report is to review the technical of satellite television on how it is created, the purpose of the antenna in the system, and the satellite television calculation that involved in this project. The technical specification part will briefly explain about the specification for the antenna and for the feed horn. The important thing for antenna is the diameter satellite dish is be between 60 cm to 120 cm, and it should have 25 degrees offset angle and 30 decibel cross polarization isolation. Next is specification for the feed horn. The horizontal and vertical polarized signal should be between 10.7 GHz to 12.75 GHz. The insertion loss should be less than 0.2 decibel. The feed horn must build to mount to the antenna as well as to the low noise block directly.
The parabolic dish antenna consists of three components: a parabolic reflector, a printed antenna feed, and the cup that the feed resides in. The dish must have a metal on the surface to reflect microwaves. The common metal of choice is aluminium. The purpose of the antenna is to intercept radio waves from the desired television stations and convert them to tiny radio frequency alternating currents, which are applied to television's tuner, which extracts the television signal. In terms of sustainability design, educational program can be provided through satellite TV, and this is related to SDG 4. These are all problems that TV satellite channels are concerned about via development programs, and these are considered as the important development issues for the sustainability and development of society. Thus, SDG 8 can be achieved.
In order for us to design a parabolic antenna, there are a few parameters that need to be considered. First, path loss, which is the ratio between the transmitted power and also the received power. In higher frequencies, the path loss will be increases to allow long-range communication. Second is the radiation pattern of the antenna. The radiation pattern for the parabolic antenna is like this. Third is the gain of the antenna. To find the gain of the antenna, first we need to find the aperture size by using this formula. Then we can find the gain of the antenna by using this formula. You must remember that the unit for the gain is in decibel. In designing a parabolic reflector for the antenna system, there are two main important dimensions. The first one is diameter and the second one is focal length. These two dimensions will affect the efficiency of the antenna system. Based on the previous experiment that had been done before, first, when we are using different focal length with constant frequency and also constant diameter, what we can find out is when we increase the value of the focal length, the efficiency of the system will also increases, but the bandwidth of the system will remain the same as it is not being affected by the focal length. The second experiment was carried out by using different diameter value with constant frequency and also constant focal length. What can we conclude from this experiment was when we increase the value of the diameter, the efficiency of the antenna system and also the beamwidth will become decreases. So as the conclusion, in order for us to design an antenna with high efficiency, we need to use bigger focal length with smaller diameter.